Greetings, my name is John Gabriel and this is the New Calculus channel, and today I'm going to be providing a new perspective with regards to Euler's S-lim S definition. In other words, you know that nonsense that you hear of 0.999 ... equals to 1 and 0.3333 ... equals to 1/3. That's all rubbish. And I'm going to show you now why it is rubbish using these graphs that I've compiled for you, and I will place links to the applet I'm using, and I will also place links to any other relevant material that I'm using in this video. So let's begin. Now, so I've defined a series which I've called S333, and really what this series does, it's this red curve here, it just increases because it happens to be this series here. Okay, in other words, 333 ... is given by this partial sum. Okay, and don't worry about the ... because when I do the arithmetic, we don't actually have to care about what happens except for the same partial sums. And some might say, but you're not dividing the entire thing. That's nonsense. All I have to do is just keep the terms aligned and the result will be the same. And I'll show you in a moment that the result is the same. So if these two series here are not well formed, then I shouldn't get 333 divided by 999 ... is equal to the third, right? But that's what I get. Divide this partial sum by this and you'll get a third. And of course, if we have the graph, it will confirm that. Look at this value here. Div 3 by 9 result is 333, right? Okay, do you see that? So if we had to go right down here, then it's undefined, okay? But as we go along all the way here, it's always going to be a third, right? So now the next thing I wanted to show you is that if we define a new object using these two, which are well defined, plus the so-called 0.999 ... which is supposed to be 1 and is given by this expression here. So this here is, this expression that you see in the highlight is 0.999 ... Okay, so obviously if we add that to this series here, we'll get 1000, we'll get 10 ... right? In essence, it doesn't really matter what the hell this number is, except that we know it's going to flip over and we're going to get some sum that has to give us consistent results if we're looking at the two objects, right? So, but now you'll see that in this case here, if you try to divide 333 ... by 1000 ... you will not get consistent results, okay? So, and this is the number down here. The only time, so the only time this will be consistent is if you can take this little dot and go to infinity. You can't. Well, as you can see here, this keeps on going towards 1/3, right? But here you have to take the limit. With these series, 3333 and 9999, I don't have to even take a limit. It's always going to be 0.333. No matter what I do, it's going to be a third, right? So there isn't any such thing as 0.333 ... That's just a load of garbage. There isn't any such thing as an infinite series. And so I'm gonna upload this applet for you and show you that it is totally delusional to talk about 0.333 ... being equal to a third, because 1/3 has no measure in base 10, okay? And I think this is just one more perspective that I wanted to explain to you, and I'll leave you with these thoughts now, and you can obviously also go to this link here where I've explained it. And what I'll do again in the video is I'll copy this text here so that you can actually go through it on your own time. And this is really hilarious because the mainstream baboons still don't admit their error and change their ways. And it's really gotten to a point where we need to resolve this. And Dedekind cuts and Cauchy sequences, I'm afraid, do not resolve anything. And neither does Euler's S equals to lim S, as I showed you using these graphs here, that if you're looking at these well-formed series here, you don't even have to bother about limits, because if you divide this object, this red object, by this blue object, you'll always get a third. It doesn't matter what you do. On the other hand, if you try nonsense like this object by this object, it's never a third, okay? Never. Since there is no such thing as infinity, this result cannot be true. Now, the mainstream is telling you that it is equal to a third, but that's false, because this here goes to a third and never actually reaches a third, does it? So 3 over 10 would have to equal to 3 over 9. In effect, what they're telling you is that 9 is equal to 10. Can you believe the fucking morons? Can you believe it? Is 9 equal to 10? And if you don't like the number 10 here, it doesn't matter, because this is some other object, okay? It actually is 10, because by Euclid's proposition 12 and book 5, it does reduce down to 10. So, but a lot of morons in the mainstream don't understand that. And I'm showing you right now that their delusional ideas have to be refuted and rejected. And there is no such thing as a non-recurring or a recurring repeating infinitesimal or a non-repeating infinitesimal. That's all just bullshit. Anyway, I hope you've enjoyed this little video, and that you'll subscribe, and that you'll spread the news, and that you'll click like. Very important to click like, because there are people who come to my site and they just basically downvote my videos so that others don't learn about this incredible knowledge that I'm sharing with you. Okay, so please share the knowledge, and be sure to download my free ebook, to which I'll also place a link, and become a subscriber. My name is John Gabriel, and this is the New Calculus channel. Till next time, goodbye, friends.